so far in physics, we have completed chapter number 5, that is heat, where we learn about the term heat, the term like temperature, and we also learn about different scales for measuring the temperature. Then again, after that, we learn how to convert degree Celsius into Fahrenheit, Fahrenheit into degree Celsius, degree Celsius into Kelvin, Kelvin into degree Celsius. And then after that, we learn about different modes of transfer of heat. Okay, so these things we have already learned about conduction, convection, radiation, application of conduction, convection, and radiation. Okay, in the textbook, questions are there. Those questions you need to write in your copy. Okay, and for the coming unit test, only one chapter I have included, that is chapter number 5, heat. Okay, the new chapter which I am going to start today, that is chapter number 6, sound, is not coming in the exam, in the test. Okay, so only one chapter is there for the first unit test, that is chapter number 5, heat. And here I will be starting today the new chapter, that is chapter number 6, sound. So chapter number 6, that is sound. Sound, again, this chapter is very interesting because it is very much related to our life. Like sometimes we become curious to know that how sound is produced by a body and how we are able to hear the sound. Okay, whenever we play the music, okay, or if someone is playing the guitar, how the guitar is able to produce the sound, at the same time how this sound is reaching us, okay, and we are able to hear it. All these questions we'll discuss here in this chapter. It's going to be very interesting. So listen carefully, each and everything. Now in this chapter, so many terms we'll discuss. The terms like sound, the terms like wave, okay, the term like different types of wave, like longitudinal wave, transverse wave, and the terms related with all these waves like crest, compression, rarefaction. Okay, then again after that, trough, crest, and then amplitude. Okay, all these things we need to clear in this chapter. So after learning this chapter, you'll be able to know about all these terms. So one by one we'll be discussing. Okay, first we'll start with the first question, that what is meant by sound. If someone asks you what is sound, then what you will be saying? Okay, like heat, sound is also a form of energy. Sound is a form of energy. It gives the sensation of hearing. Heat, it used to give the sensation of hotness or coldness. Now here how we define? Sound is a form of energy. It gives the sensation of hearing. So it is the energy with which we are able to hear the sound. Okay, hear the energy. So that is there. Then after the see how many different topics we are going to study here. First comes the sound. Then after that we'll try to know that how is sound produced. Okay, and then after that we'll learn about the term like wave and different types of wave. Okay, and then longitudinal wave and transverse wave. Okay, one by one we'll be discussing in this video. So just now I told you about the sound. That is, sound is a form of energy which gives the sensation of hearing. That means it is the energy which helps us in hearing. Okay, now question arises, how is this sound produced? Any vibrating body is responsible for producing sound. Okay, this you need to remember. Okay, so sound is produced by vibrating body. Okay, now when I say vibrating body, now what is meant by this vibrating body? Okay, by vibrating body, to understand this vibrating body, you should have clear idea about oscillatory motion and vibratory motion. Oscillatory motion and vibratory motion, they are almost same. Oscillatory motion is a type of motion in which the body moves to and fro. To and fro means about their mean position, that is rest position. To and fro means going forward and again coming backward. Going forward again coming backward, like swinging of a pendulum. So oscillatory motion. Okay, it goes up and again comes back to its initial position, then again goes up, then again comes back. Okay, such type of motion is called oscillatory motion. and vibrating also almost same. That is, in vibrating body, the body is said to be vibrating when it performs to and fro motion. Okay, that is going forward and coming backward. So, any vibrating body can produce the sound. Like when I hit this board like this, okay, I am applying the force on this board. Okay, then because of this, what is happening is that this board is vibrating, and this vibrating body is producing the sound. So just now we learned that how is sound is produced. Okay, sound is produced by any vibrating body, and then we learn about oscillating motion. Then we learn about vibrating motion. Now after that comes wave. Now just now we discussed that how is sound produced. Now we will start discussing that how sound travels from the source and reaches our ear. Okay. Now you need to understand here that for the propagation, for the sound to travel from the source to our ear, okay, it always requires the medium. Medium is always required. So that is why astronaut who goes to moon and all, in the moon, they are not able to talk to each other as we are talking right now. Okay, because there is no ear at all. So that is why when the person speaks, the another person cannot be able to hear. So sound always needs a medium for the propagation. Okay, for the to travel from the source to the receiver. Okay, so sound needs medium. Now to confirm this, you can also perform an experiment. Like what you can do is that take a mobile, okay, and then with any glass vessel, okay, cover it, okay, and then this vessel must be provided with vacuum pump, okay, so that you can evacuate vacuum pump, you can evacuate the air out of it. Okay, then what you do is that take another mobile and ring this mobile. Okay, after evacuation of air, what will happen is that this mobile will ring, but the sound will not reach us. The reason is that there is no ear at all for the propagation of sound. So by this experiment, we come to understand that sound always needs the medium for its propagation. And one more important thing you need to remember here, that the medium must be elastic. Elastic, you must understand, like rubber is elastic, rubber band. Okay, why it is elastic? Because when you apply the force to stretch it, it gets stretched. Then again you leave the force, it comes to its original form. Okay, such type of body is said to be elastic. Same way, ear is also a medium which is elastic in nature. Okay, when you apply the force to the ear moves forward, but again after some time it again comes back to its original state. Okay, so that is why the ear medium is an elastic medium. Okay, we are able to hear on earth because in our atmosphere, okay, on the earth there is the atmosphere, okay, which acts as a medium for the propagation of sound. Okay, so it's very interesting to know, student. Now, as I told you that on the earth we have ear. This ear acts as a medium for the propagation of sound. Okay, now how sound travels, in what form sound travels? To understand this, first we need to understand about the wave. Okay, let us define wave. So wave can be any disturbance, okay, which carries the energy without actually carrying the material in it. Okay, now whenever sound travels in the ear, okay, so ear doesn't go from the source to the receiver of the sound. Okay, it simply moves, okay, and passes the energy from one ear particle to another ear particle. Okay, so that is why the medium which is helping to carry the sound, okay, is actually not carried, okay, along with the ear. Ear is not actually traveling. It is the energy which is traveling. It is the energy which is traveling. Now, disturbance which carries the energy without actually carrying the material in it. Then this way, are usually of two types, okay, about which we need to learn. The first one is longitudinal wave. The second one is transverse wave. The first one is longitudinal wave. The second one is transverse wave. Now let us try to understand longitudinal wave and transverse wave. Okay, the sound wave about which we are talking right now, or about which we need to study in this chapter, is actually the longitudinal wave. Now here what happens is that they have been categorized so on the basis of how the ear particle vibrates during its propagation. Okay, when it travels from the source to the receiver, how it travels on the basis of that. Okay, on the basis of these particular things, they have been categorized into two groups, longitudinal and transverse wave. Now in longitudinal wave, what happens? There are those waves in which the particles vibrate in the direction of propagation of wave. Okay, in the direction of propagation of wave. In order to understand, see, I have drawn here one diagram. Okay, suppose this is a loudspeaker which is producing the sound. It is a source, and this is our ear. Okay, in between this there is AIR, air, and this is ear. Okay, this ear. Now, how the sound travels? It travels in the form of longitudinal waves. Okay, where the particles vibrate how? Parallelly or in the direction of propagation of sound. Now how it happens? See, when the sound is produced, okay, the energy which is produced by it, okay, is transferred to the neighboring ear particles. As a result, the ear particles come closer. Okay, come closer, and then after some time, what happens is that again, as it is elastic medium, again it comes back to its original state. Okay, during this particular time, what happens? It again goes to collide with the neighboring ear particle, where again ear particles come closer. Okay, and then again it again comes back to its original state. Okay, then again it goes to transfer heat or collides with the neighboring particle, and then again what happens is that the particles come closer. Okay, so in this way, wherever the region where the ear particle has come closer, okay, and has increased the density, okay, that particular region is called compression, and wherever the density of ear is low during the propagation of sound, that particular region is called rarefaction. Okay, so in this way, by the formation of consecutive compression, rarefaction, compression, rarefaction, compression, rarefaction, finally the sound energy reaches our ear. Okay, when it reaches our ear, then we have tympanum, that is eardrum in our ear, which starts vibrating. Okay, this ear, when the eardrum vibrates, then again the fluid present inside it also vibrates. Okay, and it produces the nerve impulse which is carried to the brain for sound interpretation. So this is how we are able to hear the sound. Okay, and here what we observe that the particle is vibrating to and fro in the direction of propagation of wave. The sound is traveling in this direction. In the same direction, the ear particle is vibrating, going forward and again coming back, going forward and coming back, going forward and coming back. So such type of wave is what we call longitudinal wave. Okay, so that's now we have learned about longitudinal wave. Okay, the best example of longitudinal wave is sound wave. Okay, now let us study about transverse wave. Transverse wave is another type of wave in which the particles vibrate perpendicularly, up and down, perpendicularly to the direction of flow to the direction of propagation of wave. Okay, so here you can see the figure also, it goes up and again comes down, goes up and again comes down, again goes up and comes down. So here what is happening is that the particle is vibrating perpendicularly to the direction of propagation of wave. So this is the direction of propagation of wave, but the particles are vibrating up and down, up and down, up and down. Okay, so that is why such type of wave where the wave particles vibrate perpendicularly to the direction of propagation of wave is what we call transverse wave. Okay, light wave is a very good example of transverse wave. Okay, light wave, or sometimes it is called as electromagnetic wave. Okay, is a good example of transverse wave. So just now we have learned about sound, we have learned about how sound is produced, where we learn about the vibrating body produces the sound. Okay, we learned about vibration. Okay, we learned about oscillatory motion. Then again after that we learned about wave, which is a disturbance. Okay, disturbance which carries the energy without actually carrying the material in it. Then we learn about longitudinal wave, two different types of longitudinal wave and transverse wave. Okay, now in the next video we'll discuss about some more new things, new terms. Okay, in this video this much student. Thank you.